Hey everyone! Today, we are going to explore some fascinating concepts in neural networks and control systems. We'll look at a Sigma Pi neural network and see how it's applied in an aircraft control system. Let's get started. Here's a breakdown of the system. Pilot input. This represents the pilot's controls, such as the joystick or rudder pedals. Reference model. This block represents the desired flight path of the aircraft. It could be programmed by the pilot or come from an autopilot system. PID controller. This is a common type of controller that uses proportional, integral, and derivative terms to adjust the output based on the error, the difference between the reference and the actual state. In this context, the output is the control signal sent to the aircraft. Model inversion. This block mathematically inverts the equations that describe how the aircraft moves. This means it takes the desired control signal, elevator movement, etc., and calculates what the pilot input should be to achieve that control signal. Aircraft. This represents the actual airplane, which responds to the control signals sent by the control system. Neural network. This block is included to learn from errors and improve the performance of the controller over time. The benefit of using dynamic inversion is that it can cancel out nonlinearities in the aircraft's behavior. Nonlinearity means that the aircraft responds differently to control inputs at different speeds or altitudes. By inverting the aircraft's model, the controller can linearize the system and make it easier to control. The neural network is there to further improve the performance of the controller. As the aircraft flies, the neural network observes the difference between the desired flight path and the actual flight path. The neural network then uses this information to adjust the weights of the PID controller, making it more effective over time. Overall, this system is designed to provide a more accurate and adaptable way to control an aircraft. Here are some additional points you might want to mention in your YouTube video. PID controllers are widely used in many different control systems, not just aircraft. Neural networks are a type of artificial intelligence that are becoming increasingly common in control systems. This is a simplified block diagram, and real aircraft control systems are much more complex. Here's a breakdown of the image Sigma Pi neural net. X1 and X2, these represent the inputs to the neural network, 1. There can be many more inputs than just X1 and X2. W1 through W4, these are the weights of the connections in the neural network, 1. Weights are essentially values that are applied to the data as it passes through the network, 1. They are adjusted during the training process to improve the performance of the network. Sigma, this is the summation function, which adds the weighted inputs together, 1. Pi, this is the multiplication function, which multiplies the weighted input, x1, x2, together, 1. Y, this represents the output of the neural network, 1. The mathematical formula for the output is shown at the bottom of the image. Y is equal to Wc plus W2 x1 plus W3 x2 plus W4 x1 x2, 1. In this equation, C is a bias term that is added to the weighted sum. It is like an extra input that is always on and has a weight of 1, 1. Sigma Pi neural networks are a type of artificial neural network that is used in a variety of applications, including pattern recognition and machine control, 1. They are relatively simple to implement and can be effective for some tasks. However, they are not as powerful as some other types of neural networks, such as convolutional neural networks.